Hello students, this video is on section 2.7, dividing fractions. In order to start talking about the division of fractions, we should talk about how multiplication and division work together to get us answers to different questions. So the first thing I want to start with is by saying that I know that 6 divided by 2 is 3. 6 divided by 2 is 3. That's a pretty standard thing to know. And if I draw a diagram of that, that's like having 6 things and splitting them into 2 equal groups. And there's 3 things in each group. Okay? But I can make this a multiplication problem as well. Remember, of means multiply. And so if I say 1/2 of 6 is 3, that's the same as me saying 6 times 1/2 is 3. So 6 times 1/2. 1/2 of 6 is 3 as well. So what we want to think is how these numbers work together, because 6 hasn't changed and 3 hasn't changed. But I have 2 and I have 1/2. So how are those related? How do those interact with each other? Another example is if I say something like 3 divided by 1/4. So think of it this way, 3 divided by 1/4. And so that's not as easy, we might not know about it right away, but that's me saying that I have 3 things and I want to know how many fourths are in them. So I have to split this into fourths and count up how many fourths there are. Just like here, I split the total into this many pieces and got this. Now I'm splitting the total into this size of a piece, and I will find that I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 quarters in 3. Okay? But I know that I can get 3 and 12 from another problem as well. And that other problem is to say that 3 times 4 is equal to 12. So in this case, it's similar, but the opposite. How do 1/4 and 4 interact with each other? Okay? What these numbers are called and the way they interact with each other, they are called reciprocals of one another. And what that means is what was on the top of a fraction is now on the bottom, and what was on the bottom is now on the top. Well, you might say this one's not a fraction at all. It's just a whole number. But because we can divide anything by 1 and come out with the same answer, we can put a whole number over 1 and it still means the same thing. So 2 over 1 and 1 over 2 are called reciprocals. Okay? Same thing here. We have 1/4 and 4. Well, 4 is not a fraction, but we can make it a fraction by simply putting it over the number 1. 1/4 and 4 over 1 are reciprocals. So if we encounter a division problem that we're not sure how to handle, we can also multiply by the reciprocal of the fraction that we were dividing by. Okay? So let me give you an example. Multiplying tends to be easier than dividing. It tends to be something students are better at than dividing. And it's no different here using fractions. There's actually not a way to divide fractions without using multiplication. So the first example we'll do is 2/5 divided by 3/4. And the diagrams, when we get into complete fractions, can be really tricky for division. So I won't even use them. What you need to know is that we can always multiply instead of divide if we multiply by the reciprocal. the first fraction always stays the same, 2/5. But here, instead of dividing, now we're multiplying. And to take the reciprocal, we just flip-flop this fraction. So 3 is now on the bottom, 4 is now on the top, and that's a problem I can solve. We just saw that in the last video, and this is pretty easy. We go straight across the top, so 2 times 4, and we go straight across the bottom, 5 times 3. And our final answer for this division problem is 8/15. Okay? So we saw why that worked before when I showed you how when we multiply by something, we're really dividing, when we're dividing something, we're really multiplying by the reciprocal of that thing. That's the only method you will use to divide fractions. And truthfully, as long as you remember it, it's pretty simple. Another example could be 4/9 divided by 1/6. Hopefully you know the first fraction will stay the same. We change the sign and we multiply by the reciprocal of the second fraction. 1/6 becomes 6/1. We now get 4 times 6 over 9 times 1, but 9 and 6 have a common factor of 3. So when I divide by 3 here, I get 2, and here I get 3. So I get 4 times 2 and 3 times 1. My answer is 8/3. Because these are fractions and not mixed numbers, you can leave it as an improper fraction. As I said before, when we're calculating fractions, it's often easier to use improper fractions. So you're welcome to leave it that way if you'd like. If you want to put it in mixed number form, you can as well. When we're working with fractions, sometimes we need to combine them or multiply them or divide them with whole numbers as well. And that's not difficult if you remember what we just talked about, when a whole number can become a fraction by going over the number 1. What that's saying is a number divided by 1 is still that number, the fraction that we're creating, still has the same value as the whole number. So if we have 1/3 divided by 6, I'm going to sneak a 1 under that and rewrite it with multiplying the reciprocal. 1/3 times the reciprocal of 6/1 is 1/6. I get 1 times 1 over 3 times 6, and 1/18 is the result of this division. Okay? Likewise, if the first number is a whole number, the same thing applies. So if we have 4, the whole number 4 divided by 3/7, I'm going to throw a 1 under there. 4/1 is the same value as 4, so I'm okay with that. And I flip the second fraction, I take its reciprocal, and I multiply. 4/1 times 7/3. That's 4 times 7/1 times 3, which is 28/3. Again, since we're working in fractions and not mixed numbers, you can leave it that way. That's fine. If you'd like to put it in mixed number form, let's see, you'd get 9 1/3. A last example I do before we start talking about mixed numbers, is one that looks like this. If I take 4/5 and then I divide by 4/5, if I divide anything by itself, I'm only going to get the answer 1 out. If there are 30 cookies and 30 students in the class, how many cookies does each student get? 30 divided by 30 is 1. Okay? So we should know the answer to this already, but let's see if it holds true when we multiply by the reciprocal. 4/5 stays the same as our first fraction. Now we're going to multiply instead of divide and take the reciprocal of the second fraction. So we're going to get 4 times 5 over 5 times 4. Okay, we have some common factors here. Let's simplify. 4 and 4 both have a 4 in them, so they reduce to 1. 5 and 5 both have a 5 in them, so they reduce to 1. So I get 1 times 1 over 1 times 1, which is a really complex way of writing 1. That's true. That's what we talked about. Any number divided by itself is that same number. Okay? We'll talk about mixed numbers, dividing mixed numbers in a second video that'll be a little shorter.